Hey, what's happening, guys? We're going to start a new build today, and it's going to be this board that you see right here, the Learn Electronics Multirail power supply. And this board was made by, and this video is sponsored by PCB Way. There'll be a link down below and a little ad later on if you want some more information about them. But for now, let's talk a little bit more about this board. So for that, we need to go to the computer, which is over here. Okay, so you're looking at my basic idea for the thing here. And I've tried to break this out into easier to read groups. So let's start over here on the left-hand side. This is our DC in, fuse, and switch. So we have our DC jack, 14 volts plus. I think we're going to change that to just use 12 volts. You'll see why soon enough. We have our main switch going into a fuse. This is not a 5 amp fuse. We're going to use a 200 milliamp fuse. Okay, so from there, we start moving into our regulation section where we have 3.3 volts, 5 volts, and 9 volt power supplies here. Okay, and you can see the main line off the fuse comes in and feeds all of them up through here. We have a power indicator which will come on when this unit is powered up. We have an output section that is going to give us our voltages: 3.3 volts, 5 volts, 9 volts, 12 volts, and negative 12 volts. To get that negative 12 volts, we're going to take our 12 volt input, which will be our main power thing there, and we are going to run it over here to the ICL 7660, which will be a negative voltage converter. You can see we have our 12 volts here, which is coming in from right here and going out over here. If you want to see what we did with it here, hang on. Here's what the board layout looks like. We start up here with our 2.1 millimeter barrel jack. Down here we have a power switch, an indicator, current limiting resistor for the indicator. We have our fuse up here. We have our regulators. Each regulator gets two capacitors. Yeah, that's pretty cool. And do this, render this 3D here. And of course, I like my boards black. And there we go. So it's going to look a little something like this. And I'll make this available on the PCB website, PCB Way website, so you can download it for free if you need a super cheap little 200 milliamp limited power supply. All right, let's get to it then. Today's video is brought to you by our friends at PCB Way, who offer a number of services to fit your needs. Currently, they are offering everything from PCB prototyping, where you can get 5 or 10 pieces for $5, assembly, $30 each, but they'll put all the components in. They do rigid and rigid flex, HDI. You can even get CNC machining and 3D printing from PCB Way. There'll be a link down below, and I highly recommend you give them a try. All right, I believe I have just about everything I need to get started, so let's get started. I was going to start with the resistor that, oh, here it is, it's over here. I was going, but there's no resistor. I'm starting with the resistor because it is the lowest profile component. And the reason we do that is so when you're soldering in new components and you have to flip the board over, you want the next component you're soldering to be higher than the last component you soldered, so that the last component doesn't get in the way of the next component. Hopefully that makes sense. Mostly I just ramble on a bit. There's going to be a little hackishness going on here. This is the first board from this, so I have a 60% expectation that it will not even work. So
Boards often take a few revs to get things precisely right. Get in the switch here. Now, I want to answer a question somebody had asked about my Navy time. They said, what did I do during general quarters as a sonar technician? Did I sit and watch the sonar screen? For those of you not in the Navy, when they say general quarters, you may have heard it called battle stations, but it is when the ship is at its most prepared to deal and to receive damage. There are many different conditions on the ship, but boats, whatever. There's too many to get into. You want to learn more? Go to boot camp. But no, my general quarters station was not in the sonar shack. My general quarters station was in the officer's wardroom, which was the battle dressing station. Alrighty. Soldering the LED here. And we're coming right along. Let's move on to the fuse next. Now here we're coming to the hackish part of our program. I have a this is a 200 milliamp 250 volt fuse, and it'll work for this, don't worry. And some of these little clippies here that aren't exactly made for this, but we're going to make them work. It's the Marine Corps motto. Don't eat crayons. No, I'm just kidding. I'm just kidding. Improvise, adapt, overcome. Make it work. Figure out a way. Man, I'm trying to thin this out a little bit, but that metal is a lot tougher than I initially imagined. Maybe I can crush it a little bit. I do not think that I can. Don't break, don't break, don't break. Oh, look at that. Beautiful. Oh, you probably can't see any of that crap, can you? That's better. Zoom you in here. I said we will zoom you in here. And we'll get her on. Now for the next one. Good, good, good. And we'll get it soldered in too. Tell you one thing, it is nice. Spring has come to the Ohio Valley, and I, for one, am very, very happy to see it. I completely blew my thing about lowest components, didn't I? Okay, I shouldn't put that one in next. Oh, well. Alright, let's solder in this. Let's put a little tack on there to hold it. And then we'll solder it properly now. Sounds like I might have to take a trip outside, though. Let's see what we got going on here. Hang on a second, folks. Hello. You need to go outside? Yeah? Say hi. Okay. Alright, so all that good stuff's in so far. I think next we're going to go down here and we're going to put in this rising block clamp that contains the outputs for our 3.3, 5, 9, and our 212 volts. I got these things going in all kind of different directions. So here's our rising block clamp to put in. It's going to kind of hide that. So I'm going to have to fix that on the next spin. Like I said, nothing's ever perfect the first time out. If anybody tells you it is, they're lying. Alright, so let's solder that rising block clamp in there. See if I can get you a bit of a better angle on it. Focus. Alright. We'll do up one of them here in the end. I just kind of want to pull that guy as straight as I can. Let that solder solidify. Then we can just go right down the line. I am currently waiting on Amazon to deliver the voltage regulators we need for this. I had a pack of them somewhere, and I can't find them anywhere. So last night, I ordered more, because, you know, got to do this video, so. Alright, what should we do next? Guess we start putting in the capacitors. These are 470 nano. Now I'll just do one at a time for each of these guys like this. Try and get you a better view. Oh, that's not too bad at all, is it? Alright. So it is April 12th as I'm putting this together, 2023. And I read this morning something that I had suspected. Who knows if it's true or not. But it said that United States and United Kingdom Special Forces troops are in Ukraine. Man, if that's true, and we got what's going on in the South China Sea, kind of scares me. I mean, are we heading for World War III here? Really hope not. But you never know. Anything could happen. So why am I using these polyester film caps, chiclet style, instead of the ceramics? I just have a ton of these on hand. What's better for this application? Honestly, I don't know. I mean, I would generally use ceramic caps, but there's really no reason that I can think of. I mean, if you know a reason, put it in the comments down below. These are the caps I use for, audio work. But like I said, I got lots of them. Alright, take a look at this solder joint here. Let's look at all of them. Let's look at them in a row. Pointer here. That one looks okay. That one looks okay. That one looks okay. That one doesn't. See how it doesn't really look like a Hershey's Kiss or a little mountain? Kind of looks more like a ball. We don't want balls. We want mountain ranges. Hershey's Kisses. Yeah. Now that is much more Kiss-like, which is what we want. So my big hope is that, Amazon gets here today, like they're supposed to, between 11 and 2:30, so we can get this video out. I know I haven't made a video all week. I don't know if you can tell from my voice, but I was sick over the weekend, and I am just now getting over it. Lots of people sick everywhere, I guess, you know. That's the way the world goes. Our good friend B-Blood down in Florida, his adult daughter is ill and in the hospital, and we're keeping her in our prayers and wishing her well. And if any of you or your family members are not doing well, I wish them well too, and pray for them as well. Some more of these guys in here. I just figured this would be a super cheap, really easy power supply for people that don't have, or can't afford a regular bench supply. These are basically the voltages you get in an ATX power supply, which are pretty much the voltages you need for your electronics hobby. So it kind of works out well. Yeah, you could buy an ATX power supply. I don't know what they cost, maybe around $100. Well, for $100 you can get a nice desktop power supply. Maybe you got an old one sitting around. You can do that. I gotta check on C9 and C11 to make sure what those values are. One moment, please. And now, in an incredibly serendipitous turn of events, the wonderful Amazon man has showed up. So, these are all 10 microfarad, and they are for the ICL 7660, our voltage inverter. So what we need to do is we need to figure out which side of these goes to ground. So we'll just hit our ground point here. No, there's that one. Now 9 is different. Okay, so this one goes in this way. Come on. Oh. And this one goes in this way. We'll solder them up. And we are just about done, which is awesome. Because it's really nice outside. Okay, so now on this one, C9 goes between pins 2 and 4 on the ICL 7660. And pin 2 is the cap positive. So we're going to go on pin 2. So positive is the inside. Am I missing a capacitor? One moment. I found it. All right, let's do this again so I know what I'm doing. Pin 2 is the inside one, so positive one goes to the inside. We'll solder that guy in. So like I said, I'm going to make this available. You can download the Gerbers from the PCB Way website, or you can order some boards there, and you can get yourself a little desktop power supply for, I don't know, not too much. I imagine it probably costs $10 to put it together, maybe, in components, unless you have the components on hand, in which case, you know, it's going to be really, really cheap to make. Get in there, and now you have to get in there. There we go. Make sure we have continuity across our fuse, which we do. Now I'm going to put in the DC jack. These take a bit of solder. Ooh, I just want to stab myself in the fingy with the soldering iron. That wouldn't have been good. I've had a couple soldering iron burns in my life. They are the worst burns I have personally ever had. I know there are obviously many worse types of burns, but soldering iron burns for me were bad. They take forever to heal and they hurt. Now that leaves nothing but our voltage regulators. Okay, so U2, first one up here, is our 12 volt. Which is the 7812. To be sure. 7812, very good. Now this is a prototype, so I'm not too concerned about the heat sinks. But if you're building these things to use on a regular basis, even though this has a 250 milliamp limit, you definitely want to heat sink these. Just trying to get them to sit nice and level. Okay. Next one, U3, is our 9 volt. U10, that's our 7809 right here. Oh, did not mean to do that. Oh. There we go. So there's our 7809. And yeah, I'm just soldering in one leg of these. Why is this one sitting higher than all the other? Because it's got little spreaders. Keep it up there for... Okay, no problem. We can correct that. Yes, I know I'm babbling. What else you want me to do while I'm soldering? Tell you sea shanties. Next is U4. And U4 is our 5 volt. Get him in there. And finally, U5. These are 3.3 volt. I don't have a 3.3 volt regulator. Well, I guess for now we're just going to have to skip the 3.3 volt. That sucks. And I'm going to take this, and I want it to be, oops, oh, not that far. Come on, get it. Just, yeah, do that. That's what I want. All right. There we go. Now I can solder the rest of them in. I thought that pack of regulators would have a 3.3. Yeah, I know it has a 317, but that's an adjustable regulator. I ain't set for an adjustable regulator. It's still a little crooked. Here we go. Here's straight. Yeah, it's like 80 degrees up here. My air conditioning just kicked on, which is a good thing. Back in December, I had to have my furnace worked on. They replaced the thermostat and the control board. So I knew it was going to be warm this week, so the other day I went to just make sure everything worked. Flicked on the AC and I got nothing. So I went outside, I checked the breaker on the fan thing outside. I know it's not called a fan thing, it's called something, I don't know what it's called. I'm not an HVAC guy. And it looked fine. Went downstairs, checked all the breakers in the furnace, they looked fine. Looked at the control board for the error code. It was fine, no error codes. So I called the contractor who repaired it. They came over. Guys, almost started the thermostat. I'm like, okay. He opened it up. He goes, oh, there's your problem. He goes, you didn't hook up the air conditioning wires. Now, yes, I know I could have done and looked for all that stuff, but since I paid those folks almost $700 previously, I figured they could come and look at it themselves. All right, well, we got no 3.3 volt regulator, but other than that, I think it's ready. Okay, we have come to the part of the program that I like to call relieve yourself or exit the laboratory. Let's see if she works. We got our power coming here from our power supply. What the heck is going on here? Power supply is on. Did the fuse blow? Or are we just not getting good contact from the fuse? Huh. What the heck? Yeah, it would appear as if this fuse is bad. All right, there's a good one. We'll put the good one in. Nope. Not that low, man. Jeez, look at that. Oh, it's slipped behind. Holy cow. These little fuse dingle bobs are just no fun to play with. Get in the right place. There you go. Alright, let's check it. I just want to make sure the fuse is good first. Good. Alright. Things good. Yeah, that pulsing is a little strange. Let's see what we get. Ground, -12. My ICO isn't doing anything. Okay, something's wrong. Get that out of there. All right, see what we got now. Oh, wrong voltage, Paul, you dum-dum. Ground, 12. Oh, -12. There's 12 volts. Okay. 9 volts. 5 volts. Well, something's not exactly right. And I'm guessing it's something to do with this ICL 7660. Maybe this one was bad. So I'm going to grab another one. Hang on. All right, here's my package of ICL 7660s, which I can never get open. I don't do well with these little Ziplocs. I just cut them open and they end up going in the parts cabinets anyway, so it's not really a big deal. All right, here's another one. Let's try this one. Because everything else is working fine. All right, let's try this. See what we get. Nope, same thing. There's a problem with the 7660. But is it really a problem with that? Or is it a problem with the way the capacitors are in? So let's make sure we got continuity to the right sides of these. Yep, there's a problem right there, C9. C9 apparently is in backwards. One moment. Okay, as you can see, I put in a new ICL 7660. So let's see if that works. You can see we're not pulsing anymore either. Ground. There's our 12 volt. Oh, you can't see that. I'm sorry. I could be telling you it's anything. All right. So there is our -12. And then our 12. Let me just make sure the other ones are good. 9, 5. Oh, not going to get anything out of 3 now, are we? Well, there she is. There she blows. Hope you guys enjoyed this little video. If you did, give me a thumbs up. Like I said, I'll make this available. And I'd like to thank PCB Way for sponsoring this channel and, just being generally good guys. All right, guys, that's it. I'm out. Thanks. Peace.